This example comes out of section 6.3, proving identity. We're asked to prove this identity cos x, sorry that cos x doesn't look very good, cos x divided by 1 plus sine x equals 1 minus sine x divided by cos x. This is a classic identity where if you look at your hints for proving, there is no more complicated side, they're equally complicated. There is no identity that springs off the page and says use me. To simplify that, changing things to sine and cos doesn't help because they already are. Factoring doesn't work because there's nothing to factor. Carrying out fraction operations doesn't change these really at all. So what we're looking at is multiplying by the conjugate. This is a conjugates example, and what the clue is right away that I have a 1 plus sine x on the left and I have a 1 minus sine x on the right. So on one of these sides, and really it doesn't matter which, since I have a slightly more room on this side, I'll use the right side. I'm going to multiply by the conjugate top and bottom, meaning if I have 1 minus sine x, the conjugate is 1 plus sine x. So I multiply by that on the top, which means I have to multiply it by it on the bottom. Because I'm now just multiplying by 1, I'm not breaking any rules. But 1 minus sine x times 1 plus sine x is 1 minus sine squared x. On the bottom, I don't even bother multiplying them together. I just leave it as cos x times 1 plus sine x. The beauty of the numerator is that 1 minus sine squared is cos squared. So cos squared over cos x times 1 plus sine x. One of the cosines cancels out top and bottom, and I'm left with exactly what I was hoping to be left with, which is an expression that looks exactly like the left side, and my identity is proven. That is the tool of using conjugates. You only see it in very specific proving examples, but it is a handy tool if you see a conjugate of an expression on the left as compared to what's on the right.